This is an appropriate time for you to think about the organization of the autonomic nervous system. An autonomic ganglion has a fundamentally different function from a sensory ganglion. Each sensory neuron runs all the way from a sensory organ, say in the skin, to the spinal cord. In contrast, two neurons make up an autonomic pathway for both sympathetic and parasympathetic pathways. The first, preganglionic neuron, has its cell body in the spinal cord or the brain. Neuron cell bodies of preganglionic sympathetic nerves are located in the thoracic and lumbar segments of the spinal cord. Neuronal cell bodies of preganglionic parasympathetic nerves are located in the medulla and midbrain and the sacral portion of the spinal cord. The first preganglionic neuron sends its axon out to make a synaptic contact with the dendrites or cell body of the second postganglionic neuron. That second neuron sends its axon to the distant target, maybe a glandular cell or smooth muscle. Sympathetic second neurons are located in small ganglia alongside the vertebral column. Parasympathetic second neurons are located in small ganglia very near or even within the effector organ or tissue. And for this reason, a sympathetic first neuron is short, but the second neuron is long, as it needs to travel some distance from alongside the vertebral column to the effector organ or tissue. The opposite is true for the parasympathetic first and second neuron. So this sympathetic ganglion in the background image, and similar to the one you just looked at, is where the postganglionic neuron cell bodies are clustered together, and also where their dendrites and synapses are. The ganglion cells are multipolar with multiple dendrites for synapses to form on. Therefore, the satellite cells surrounding them cannot form tidy sheets as you saw within the spinal or sensory ganglion, but they look scattered. This is the way to distinguish sympathetic from sensory ganglia. Also, there is a substantial amount of neuropil in the ganglion. That is, blank-looking areas where invisibly tiny branches of axons and dendrites intertwine and synapse. Presumably, the autonomic nervous system uses a two-neuron strategy as an amplification mechanism. A single preganglionic neuron in the spinal cord might synapse with dozens of postganglionic neurons.